Hello everyone, welcome to Discrete Mathematical Structure, Module-2, Session-7. So in the previous session we were discussing about the principal counting as the part 1, and I had introduced you permutation, and I just told you that we are going to discuss about permutation. In the next session we are going to discuss about combination, or let me introduce you the combination. Yes, sticking to that plan. In this session, I am going to introduce the combination to you and how exactly this permutation combination is related with each other. I will just come at that point, but before that, so just to give a quick glance of exactly what has happened as part of permutation is that we discussed what is permutation, and while telling what is permutation is all about, I just took a sort of examples, and I told you permutation is something where I'm going to have n objects and you need to pick r objects. And this is what you exactly need to do. And when I want to find how many arrangements I can make, just listen the word what I'm using, arrangements. Whenever you're going to use permutation, so this is going to act as a keyword to differentiate permutation from combination. Hence, just listen the word carefully, the arrangement, the word what I'm using here. I'm going to have n objects. Out of the n objects, I'm going to pick r objects, and I'm going to look into the arrangement, how exactly this n objects, picking r objects out of it, I'm going to arrange this r objects. That is what permutation is going to all about. And even I gave you what is the form, or the general form of the permutation is going to be. With this, even I just gave you 3 cases where the case can be the n and r can be equal, where the value of r can be 1, or where the value of r can be anything in between n and r. So this is what the 3 cases I produced with you, and generally I gave one more general form, that is to work with the frequency of objects, identical objects, though they are distinct, still they can be identical. In that case, and when the value of n is r equals to n, what the general form is going to be. And even I discussed a few examples with you, something like starting with the ABC as a dummy character, and the flower, the success, and the books in the library. So the few examples which we have been discussed with. So today in this session, let me give few more examples with respect to permutation. Then, as I said, let me take you into the concept of combination. Fine. And so let's just look at some examples. Fine. So now just take this word sociological. Fine. I am just going to take the word sociological. Sociological. Fine. Now this is the given word, and whenever I'm going to give the word as an example with respect to permutation or combination, don't look this as one single object. What exactly we need to do here is, I need to look this as combination of objects. And what are the objects here? The characters or the alphabets will stand as a distinct object. In that case, just see how many objects are here. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So first of all, let me note it down. There are 12 objects. Hence I am going to say n equals 12. So now I am not giving any r value here. Without giving you the r value, right now I am asking you to find the number of arrangements. Find number of arrangements for the given set of objects or for the given word. Now how do you do this? So now this is the case whenever the value of r is not given, by default don't assume this to be any value, or even don't assume this to be 0, or even don't assume this to be 1. Whenever there is no r value given, by default r value will be same as the n value. This is the one thing we need to keep in your mind. So never, when there is no r value available, don't try to search for r value. Straight away go and by default say that r value is n value, because when I'm given you n objects, And if I am asking you to find the arrangement of n objects, you need not think you need not ask me a question how many objects you need to pick. I am given you all objects and I am asking you to make or find the number of arrangement of those objects. Hence, for that reason, R value will be same as n whenever I am going to give whenever I am not going to give the R value, and whenever the value of n is going to be equivalent to R or R is equivalent to n, what is the general form I am going to use? So now let me put it over here. So in general, so NPR or the standard way what we have written all these times, let me put this as n of P of n comma R, so which have been defined the form as n factorial divided by n minus R factorial. This is the general form. Even I can apply the same form even if the n is equal to R, but I have a shortcut form to solve such problems. What is the need of using the same general form? And so whenever the value of n is equivalent to R, I am going to say P of n comma n. And why I am using n comma n? So without doubt you need to know that value of R and n are same. It doesn't matter whether I use n here or whether I am going to use R over here. So in that case I am going to have this as n factorial. Now again I need not explain you why I am just writing n factorial over here. So now this is the first general case what I need to think about. Now should I stop at this? No, because whenever you are going to find the number of arrangement for all the n objects, keep in mind to think about the frequency also. Should think about the frequency also. That is the number of identical objects which is available in the given set. I should work on the frequency also. Hence, I am going to divide the number of arrangements what in general I am going to compute this with n1 factorial multiplied with n2 factorial multiplied with so on nk factorial. Now what is n1, n2, nk? So n1 is a type of object, n2 is type of object. It is something like I am going to have a basket of fruits and I am going to say there are 3 apples, there are 5 oranges and there are 2 bananas. So this is how I am going to have a basket of fruit, but still I can segregate or group this as kind of fruits. That is what the frequency is going to be all about, or the n1, n2, so on, nk is going to be all about. And this is the general form what I am going to use. Hence, in this scenario I am going to use this general form. So now I know what is n, hence I know what is even R also. Hence, so P 12 comma 12 is equivalent to 12 factorial. This I can do it straight away. But now the next thing comes is I need to find the frequency here. So let me find the frequency. So first of all let me take S, which is n1. Let me say n1 equals S, the frequency of S, which is equivalent to 1. That's going to be only 1. Hence no much confusion. Let me say as 1. And let me now take n2. So now n2 is O. I am going to take as O. Now how many O's are there? 1, 2, 3. There are 3. Hence the frequency of this is going to be 3. Now what about n3? n3 O is done. So next I'll just take C. I'll just take C. So C is 1 and 2. There are 2 C's. Hence I'm going to write the frequency as 2. And now let me take n4, which is equivalent to, so I is not done. Let me take this as I equals 1, 2. There are 2 number of i's, hence I'm going to rest 2. So let me continue this. I'm going to have n5, which is equivalent to, so I've done with I. Let me go with O. So O is already done here. I need not do it again for this case. I'm going to pick L. So L equals, how many L's are there? 1 and 2. I'm going to have 2 L's. Fine. So next let me take N6. Fine. And I'm going to have O. It's already done. I need not count again. I'm going to have G, so G is not done. So N6 equals G, and how many G's are there? It's only one. Fine. So next, I is done already, and C is already done. So I should take up E, because the next, if I talk about L, again it's done. Hence I'm going to have N7, which is going to be A, and which is going to be 1 again. So this is the different kind of objects. There are 7 different kind of object, hence I can say K will stand at 7. Fine. So now just look at this. Just look at this. Now if I am going to add up, all this, that is, I am going to add up N1 plus N2 plus so on plus Nk. That is 1 plus 3, 3 plus 2 is 1 plus 3 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 1 11, 11 plus 1 12. So that means I end up with 12, which is again same as N. That is what we say. There are 12 objects, but I have been just put into group and put over here. So this is how I need to talk about or think about frequency whenever I'm going to use this. So now this frequency should be brought here with N1 as 1 factorial, hence 1 factorial multiplied with N2, which is 3 factorial into 2 factorial. This is done. N4 into 2 factorial. This is done. Again 2 factorial, 1 factorial and 1 factorial. So 2 factorial into 1 factorial into 1 factorial. Is it fine? So now this is the form what I am going to use. And you know what is 1 factorial? It's 1. Find what is 3 factorial, 2 factorial and so on. So solve this. Whatever the result you end with, that is the number of arrangements for the given characters or for the given set of objects. This is how I am going to work with if no restriction has been given. That is, if I take this as the problem and no conditions has been given, this is what I am going to have. So now let me put n condition over here. Let me just put a small condition over here. The condition is A and G should be together or should be adjacent or adjacent. So now what do I do now? What do I do? A and G should be adjacent. In that case, find where is A. So this is A over here and this is G over here. So now what does this means is the arrangement what you are going to consider now, the arrangement whatever you are going to consider, that arrangement should always make sure that G and A are always adjacent. That is, either I am going to have sociological. Now this current word whatever you are seeing as one of the arrangement, this cannot be part of my solution because G and A are not adjacent, because after G the adjacent is I or before G adjacent is O. Hence when I say adjacent, either A should be next to G or A should be before G, or I'm going to have any sort of arrangements again with G and E. But right now let not think about all those things, but let me write it down for you. So now A and G should be always together. Hence let me take this as one object now. It is something like I am going to pick an apple and I am going to pick an orange. I am going to combine this. I am going to tape it out and I am going to tie and make this as one object now. So this are together now. This is going to be together. Yes, so now when I pick an apple, obviously the orange will also come with that. If I pick an orange, obviously the apple will also come along with that. Hence we consider this as one single object at this point of time. Hence this one object for me. And now check out for remaining. So I am going to have S, O, C, I, O, L, O, G. I am not supposed to write G because G is already here. I'm going to have I, C and L. Now just count here. 1, because the entire thing is one object for me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now there are 11 objects. Hence n equals 11 for this given condition. Is it fine? So now for this given condition, I need to find the arrangements. To find the arrangements, because I need to consider all the n value, again I should make use of the same general form. Hence I am going to have P of 11 comma 11 equals P of 11 comma 11, which is going to be n factorial, that is 11 factorial divided by, now again work on the frequency. Now S, I have got one frequency, O is the same, C, I, frequency will not change. If you want, you can just check it out again. And L is the same frequency. Now only this G and A will have how many frequency, how many occurrence? Now G and A is going to be only one occurrence. G and A is only one occurrence. If we add G and A again, once again somewhere over here, it would have been two occurrence. But right now it's frequency 1. Hence I can combine this and I can say this is going to be one frequency. Right now I end with only 6 type of objects. Fine. So now hence I am just going to put the same, everything is going to be same, 1 factorial into 3 factorial into 2 factorial, again 2 factorial, again 2 factorial, and this need not written over here because already we know what is this. So find what this is going to be. This is what I have been, find the solution for this, but I have not yet completed. I am saying the solution is not yet completed because just observe this A and G. Now what I have done, whatever the arrangements I have been found by solving this, it is for the arrangements where first A will appear, then followed by G. But this is not the case always. When I say adjacent, so G and A can also be the adjacent. Hence I need to even think about the next set of combinations. Sorry, I'm using a general word combination here. The next set of arrangements which is going to have the adjacency of G and A by flipping out. So how many ways? So if this are, for example, if this are 10 ways, and for this I'll be having 10 more ways, that is the double of this. Hence for that reason, whatever the solution you are going to find, you need to multiply this with 2. So you multiply this with 2. I'm multiplying this with 2 because just look this as a small sub problem now. The small sub problem what I have been given here is I have given AG. Now you need to find the number of arrangements for this. What is n? N is 2. What is r? R is again 2. Hence, so when n and r are equal, I can use general form. When I use general form, the frequency are still 1. Hence, I need not use the general form. Directly I can say n factorial and the value of n is 2. Hence, I am going to say this as 2 factorial. Multiply this with 2 factorial. So this is how exactly I am going to make use of when certain condition is going to be. I hope I am clear with this. So now just to give a bit more idea exactly how this was working, so let me take up and one more condition along with this. The next condition what I am going to consider here is, fine. So let me take the next condition, the third condition, so which is going to say that ovals, and I know what do you mean by ovals, that is all the ovals of the given word should be adjacent or should be together. That is what. So right now in this condition I had used only A and G, but now all the ovals should be together. Now I am not going to elaborate in this way, but let me give an idea. So what are all the ovals is going to put at one side? So S is a oval? No. So hence I am going to have O is a oval. I am going to have O, and I is a oval, and there is one more O, and there is one more O, and there is I, C, A. I is going to be an oval. Fine. So now just write the remaining words now. So S, O is done. So S, C, I is done, O is done, L, O is done, G, I is done. So C and L. Let me count first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fine. So these are the holes which should be together. Now I am going to consider this as one object now. Consider this as one object, remaining as different objects. And so how many objects you have got? 1, 2, 3, 4, 5, 6, 7. The value of n right now is 7. Fine. So let me just erase this. Fine. So now the value of n is going to be 7. Hence, how do you find the permutation? So P of 7 comma 7, that is equivalent to 7 factorial divided by this entire thing is one frequency right now for me. Hence 1 factorial multiplied with S is going to be only once. Hence 1 factorial. C is twice. Hence 2 factorial. L is twice. Hence 2 factorial, and G is once, hence 1 factorial. This is what I am going to get as the first part. Fine. So now I should not stop at this. I need to find even the arrangement, because every time it's not going to be in such a way. It is going to take its own arrangement. And again, look this as sub problem. Fine. So when I look this as the sub problem, we are going to have 1, 2, 3, 4, 5, 6. And P of 6 comma 6, this is equivalent to, I am going to have 6 factorial divided by, so O is 3 occurrence, hence 3 factorial, I is 2 occurrence, hence 2 factorial, and A is 1 occurrence, hence 1 factorial. This is fine. And the final solution will stay as P of 7 comma 7, whatever the value have been founded by computing, and I am going to have P of 6 comma 6. So this is how exactly I should think about the permutation. Fine. I hope you're clear with the concept what I have presented over here. So we'll just see the next example. Fine. The next example is, I am going to give set of digits. The set of digits are 3, 4, comma 4, 5, comma 5, and I am going to have 6, comma 7. So the set of digits what I have been given, and you need to form a number, an integer number using these digits, which should always exceed, or which should be greater than or equivalent to this number. And how this number is read? It's left to you. So it's going to be 50 lakh. Fine. So what are the number you're going to give me now? As an arrangement, you need to make sure, the only condition you need to make sure that it's going to exceed the given number or the condition. So for this, what I should use? So if that's the condition, just look into this. Now, if I am going to consider this as n1 or d1, the digit 1, and the digit 2, digit 3, digit 4, digit 5, digit 6, and digit 7. There are 7 digits which I should think about in the available number of digits. So now I should pick 7 digits out of 7 digits. Right? Hence the value of n is going to be equivalent to r. That's going to be the case. Hence I am going to use this condition now along with the frequency. Fine. So now for that, now just look at this. Now what the d1 can be? Now can d1 be 3? If it is 3, it is not going to stand at 50 lakhs. It is going to be starting from 30 lakhs. I cannot say d is going to be 3. Even the same case with 4. Again with 4, the only available case are 5, 6 and 7. So now this the 3 cases where I can make sure that the integer what I am going to form is going to be greater than 50 lakhs. In that regard, I can say this is the case 1, case 2, the case 1 when the D1 is 5, case 2 when the D1 is 6, and the case 3 when the D1 is 7. So let me take this as case by case now. So in the case 1, when D1 is equivalent to 5, that is I have used one digit out of the n objects. So my one job is done. So remaining how many? Now this is done. I should think about now 6 more digits. With available 6 more digits, again the value is still same, hence I am going to have the permutation of 6, 6, which is equivalent to 6 factorial divided by this one occurrence of 3, hence 1 factorial, and there are 2 occurrence of 4, hence 2 factorial. Now there is how many occurrence? It's 1 occurrence because I've already used 5 over here. There's only 1 occurrence left out with. Hence I'm going to have 1 factorial, and I'm going to have 1 factorial multiplied with 1 factorial. So find the solution for this, or find what I'm going to end up with. This is the first case. The second case, that is D2 equals 5, where I am going to have I'm going to have D2 equals 5, where I am going to have D2 equals 6, and so if I am going to use 6 over here, again I am going to say D1 is 6, so this is going to be D1 equals 6. When D1 equals 6, again I have been left out with 6 more, hence I am going to choose as 6, comma, I'm going to have 6, comma, and I am going to have 6 digits again out of the lot, and now I am going to have 6 factorial divided by, check out the frequency now, again it's going to be 1 factorial multiplied with 2 factorials multiplied with 2 factorials multiplied with 1 factor, because it is already used over here. It is already used. So this is what I am going to find out with. Now just go for the next case, that is D1 equals 7. That is again P of 6, 6. Hence I am going to use this as 6 factorial. Similar to that, I am going to have 1 factorial multiplied with 2 factorial multiplied with 2 factorial multiplied with 1 factorial. So this is how I am going to solve this particular problem. So let me call this as P1, P2 and P3. So to find the final solution, you need to call this as P1, whatever you have find, multiplied with P2 and multiplied with P3. So now I am going to multiply. So should I do multiplication here? So I am going to do it separately. The case 1 is separate from the case 2. I am not doing everything at the same time. So in the previous example, what you had seen, I had part of the problem which was done, and the remaining part was supposed to do along with that. But in this case, that's not the case. I am going to find the case 1 separately and tell how many ways. Separately I should do this, and I should not combine this. I should not combine the 7 digit again with the 7 digit. I should not combine. Hence for that reason you need to use a sum rule here, not a product rule. This is how you need to solve this problem. Let's take this example now, where I am going to say 2p. So 2p of n comma 2p of n comma 2 plus 50 is equivalent to p of 2n comma 2. Right? So this is the given condition. So now what you should do? N is going to be, I need to find what is n. Hence find n. In this case, I know what is 2. I know what is 2, or I know what is p of n comma 2. Just substitute over here. Hence I am going to end with n factorial divided by n minus r factorial, where r is going to be 2, hence I am going to have 2 factorial plus 50 equals I am just going to have 2n factorial divided by 2n minus 2 factorial. So solve this equation by having 2 multiplied with this. So solve this equation where you are going to end with so n square equals 25 and n is going to be plus or minus 5. So when you find such problems, so this is exactly how we are going to substitute the general equation, and you're going to try to find what n is going to be. I'm not elaborating much how exercise is done, but if you think about how you're going to put this into an equation to solve as a quadratic equation, then you will know how I arrived at n square equals 25 and n is going to be plus or minus 5. So this is what exactly you do with such problem. So now as I told you in the beginning class, now let me move on to the combinations. Let me move on from permutation to combinations, and I will just show you what exactly the combination is all about and how it differs from an permutation. Fine. So now just look at this. Until now we were discussing about permutation, that is P of n comma r. So now is the time let me introduce you the combination. So when I say combination, let me say this as C n comma r again. I'm going to call this as C n comma r, where C stands for combination. Hence we are going to talk about some combinations over here. Fine. So now to understand the permutation, the combination, now just look at this. I'm going to have A, B and C. I'm going to have A, B, C. Now there are 3 objects. That is the value of n is 3. And now out of these 3 objects, I need to pick 2 objects. And I should check out the arrangement. Hence I'm going to say r equals 2. So if I am talking about permutation, I am talking about arrangements now. That is, so now picking 2 objects, how many arrangements I can make? Now out of these 3, the first way is going to be, I am going to pick AB, and the next combination will be I'm going to pick AC, and the next I am going to pick BC. I'm going to pick BA. I'm going to pick B, or let me write it over here. So BA. Fine. So I'm just going to next pick CA. Let me put it over here, and I'm going to pick CB. Fine. So this is the ways I'm going to pick 2 objects from the given n objects. And the similar way, just look at in this case, and just look at in this way where I'm going to end with 6. Number of ways is 1, 2, 3, 4, 5, 6. Hence if I substitute for P, I'm going to end with that is, I'm going to have P equals, or a P of what is n is 3, that is 3 comma 2, which is 3 factorial divided by 3 minus 2 factorial, which I end with 6. Fine. So now if you just carefully observe, AB, I have been picked AB, and I am going to have BA. I am thinking about arrangement right now. But now when I talk about combination, I never think about arrangement. The combination is just, I am going to have set of objects over here, and from that set of objects I need to pick 2 objects. I never think that whether I am picking the first object and then whether I am picking the second object, or I am picking the second object first, I am picking the first object next. I never think about it. What all I want is, in any way I need 2 objects. Whether I pick both at a time, first is the first object, second is the second object, or the first is the second object, second is the first object, I never think about the order. If such is the case, then think about combination. Whenever the order is not a specific condition, at that point think about combination. So now if the order is so relevant and the arrangement what I want to look into, then think about permutation. That is what I am doing here. I have picked AB. Along with AB, I am thinking about BA also, because these arrangements, this is the number of arrangements what I want to think about. But whereas in the case of combinations, as I told you, need not think about the number of arrangements what you make. So now I am going to pick AB. When I pick AB, I should not think about BA again. I should not think about BA because I have picked two objects. I never bother about the order now. So AB is equivalent to BA for me in combination. Fine. So similarly now AC. Now AC is equivalent to CA. And I am going to pick BC. BC is equivalent to CB. That's enough. So when these two ways are same for me, I need not count it twice. I should count it only once. Hence I am going to have 1, 2 and 3. Hence I am going to have 3 ways. There are 6 arrangements in permutation. There are 3 ways in combination. So this is how I am going to think about. Now how I can relate the permutation with the combination now. Just think about this. When I am going to have a permutation, picking the object is the first task. The second task is I think about the arrangements. I am doing an additional job. If you talk about, I am doing combination here. Along with the combination, I am doing arrangement also. Hence, that is the one additional task what I am doing in permutation comparing with combination. That is what we say. That is what we are going to say. The permutation, whatever, the combination, whatever I am going to have, I am doing an arrangement of two objects, that is AB, to stand as BA. Hence, how many objects I have picked? 2 objects. Hence, out of these 2 objects, always I think about the arrangements. I pick 2, then think about the arrangements. A number of ways of arrangements. That is R factorial. I am going to R factorial. If it is 3, 3 factorial. Right now it is 2 factorial. Hence I am going to end with 2 arrangements. Hence in general I am going to say this R factorial. Now the combination what I do, and along with the arrangement the second task what I do, that is what I have put over here. The combination as well as the internal arrangement of the objects picked. This is equivalent to permutation. Fine. This is going to be equivalent to permutation. So this is how I am going to relate the combination with the permutation. So now you know what is C, which we call this as C of n comma r equivalent to, now you know what is P, that is P n comma r. I am going to have P n comma r, and now this should be multiplied with R factorial. So now at this point of time, you know what is P n comma r. You know what is P n comma is n factorial divided by n minus R factorial. And so let me put it over here. So I am going to have this as R factorial into, so C of n comma r equivalent to, I know what is P now, that is n factorial divided by n minus R factorial. So now I am just going to have this as C of n comma r equals n factorial divided by n minus R factorial, and I am taking this to the denominator. I am going to multiply this with R factorial. Now this is what the combination is going to be all about. So remember what is permutation and remember what is combination. Fine. So this is how you need to think about. So right now understand the relationship between the permutation and the combination, the relation between these two, how exactly it is going to be related. And along with this, whenever I am going to have a permutation combination, when do I think this? When I am going to think that I need to make use of permutation here, or when should I am going to think I am going to use a combination over here. So for that for this instant, let me give an example and clear your doubts as much as possible. Because the examples, let me take in the next session, but in this session what I want you is think about when should I use permutation and when I am going to use a combination. So now just think about or take this example. Example is something like I am going to have a locker. There is a locker where the locker is secured by 4-digit code. Fine. So now I need to crack this. I need to crack the code. And why should I crack the code? If I was a owner of this locker, I need to crack it now because I have forgotten the code. Or second case, if I am not the owner of the locker, then I'll think about cracking the locker so that I need to steal something as a thief. I'm thinking as a thief now. In any case, keeping aside in any case, now I need to open this locker by using a proper 4-digit code. So now the number of available digits are 0 to 9, that is there are 10 objects, n value is 10, and how many digits you need to enter now? That is 4. That is going to be R. That's out of 10 objects I need to pick now 4 objects. N is 10, R is 4. Now do you think about permutation, that is Pn comma R, or do you think about combination Cn comma R? Now which formula I need to use to say how many ways are there, so that I can find one right way which is going to help me to open this locker. Fine. So opening a locker, we'll take it as its next part, but the first part is I need to know how many ways are available for me so that I am going to open this locker. So in this scenario, do you think about permutation or do you think about combination? So now, if I am going to pick 4 objects from the 10 digits what is already available, what do I do here? So do I think about combination here or do I am going to think about permutation here? So just give a thought until I meet you in the next session. Until that, think over this example. Should I use a permutation here or should I use a combination here? So which is the best way of dealing such scenario? And I'll just give examples and let you know still more clearly what is permutation and what is combination and how should we go with these two concepts. Thank you for this session.